Wrong one. So I hope you enjoy, and a big round of applause for Dmytro. And take it away.
Yeah, thank you very much. I hope you hear me well. So I think we can start, and I will tell you about the large-scale login made easy. I'm a software engineer from a company named Victoria Metrics. My name is Dmytro, and we developed scalable and maybe someone heard about Victoria Metrics monitoring system and about Victoria logs. So I want to tell you about the Victoria logs and how it works, why we develop it, and why we want to that different companies use it. I want to ask some questions to you. How many people use Elasticsearch on your production right now? Okay, and how many people use Grafana Loki right now? Oh, okay, so 50-50. Yeah, it's cool, it's cool. So I hope you know a lot about the logs, how they works, and what is login is, and how they structures, and I hope you know how they works under the hood. So what is login? Right now you can see that there is some pretty cool logins. It's the example from our Victoria Metrics instance. It shares its logs, and we can see how it looks like. And I hope your application has the same login like this. And what is it? For example, what is the log line? It's full information about what happens on your application. It uses some information and shows to the user in the console. It contains with timestamp, with info, with with log location where it happens and where your developer entered this message, and we can identify exactly what happens and where it happens and why it happens. I hope you know what is the log level and which levels you have. Yeah. And this is a log message, and this log message always shows and tells to developer or SRE engineer or DevOps engineer what happens and how it works and what we should do if we have some, for example, error or warning messages. So what that is the login. Why we should use login in our system, and what's the purpose of our login? The first purpose, and maybe the mainly purpose why we should use it, it's a debugging of our system and how it works. And we should know what happens with our applications, and maybe when we have some error, we should understand where this error happens and what the error is. On the examples, when we have some questions, we showed for the Victoria logs queries. I will make after my speech. I will show you some examples how we can use Victoria logs from the console. It has vlog CLI, but I will tell you about it a little bit later. But right now you can see the example how you can get the error messages from for the last 1 hour. Why? The app returns the unexpected response. We can check it. For example, we want to understand how many we get responses not equal to 200, and we want to check it what's the reason and what the application returns this status code. There is some simple example how we can do it via the query. It's the second purpose of login. The third purpose of login is why our application do not work or didn't work correctly yesterday, we can check it by some time range or just enter the one day and check what's up. But we need to be sure that in our log message we have the label app, for example. No, it's just our example, so you can imagine you have your system with your labels. Sorry. And the fourth purpose of login, what we are doing at the what app was doing at the particular time range, and we can enter the time range and check what happens with our application, some application in our time range. The next purpose of login system is security. Some of the DevOps engineers and SRE engineers should check what happens with their infrastructure and maybe some developers can, for example, drop your database in a production and you should know what happens and who do it, and you can just enter drop database message in your query, and the log system should show you the whole information about via this message. If you find it, you should check what happens in your production with your database. The second purpose of login security, it's for example, what IP addresses were used via the login as an admin user or another user, you need to check. This is some simple examples of the queries, and you can filter it while unique IP, and you can count the number of IPs you have while the admin entered to your system, for example. And the another simple reason, it's who transferred money from my account. No, it's mostly related to bank systems. When some users make some transactions, and you can see who made this transaction and what's the reason of this transaction. It's for example. Another security purpose is how many failed login attempts during the last day, and you can see the information. You can collect the information about failure in some systems, and you can count it, and you will understand what the system works incorrectly and have some failures. And after that, you can find this information via your log messages. Another purpose of login is statistics and analytics. So you may request the cert some. For example, you can count how many requests were served per the last day for the last hour, and you will understand how your system works and is it the capacity enough for your system. The second purpose is accessing how many users have access to some application for some time range, for example, for last month, and you will check you can check these users, and maybe some users do not have the access to this application. The next request is how many from what IP ranges you have requests, and you can check it via some simple query, and you will see from what IPs was those requests, and you can remove these IPs from your IP tables, for example. And this is a little bit interesting query. I will show you it after my speech, how it works. It calculates the percentage of your error messages, what you have in your system, and you will understand how many errors you got all around for example, your Kubernetes cluster. And you can calculate the quantile from your request durations, no, it's just imagine you have some field name request duration, and you can calculate the 59 percentile of requests for the given. I mean, for the given web page of the given some server or service or something like that. So what I want to tell you about the stats and analytics that you can build with the login system, the statistics, and show different graphs, and you can analyze it and make some decisions on this analysis. So what we are doing for the 15 years since 1917, we are using traditional login. So how it looks like, this is logs from some local file system, and it has different syslogs, some kernel logs or boot logs, and they lay it in the varlog folder, and you can always see it. And how some DevOps and SRE engineers work with it, they most of they use cap, grep, AVK, and different command line tools to analyze and to check some logs and get some information, build some statistics, etc. But as you can see, it's quite hard to build some interesting, to get some interesting information. And if you're not familiar with Bash, it would be not trivial to get some statistic information from your logs. What is the advantages of the traditional login? It's easy to set up because all the tools you have from your Linux system. It's easy to debug because you always have your files on the system, and you always can check if everything configured correctly, and you always can check it on your file system. It's easy analyze with command line tools because all tools has everything you need to retrieve the information from the logs file and check some lines of the logs, etc. And they works perfectly for 50 years, so it's quite good. But what is the disadvantages? The first disadvantage is it's more reason, and it's maybe some of the first purpose why it's hard to analyze logs from the thousands of hosts, because some of the people feeling of power when they are trying to run their microservices on Kubernetes. The second one, the same. It's when your boss comes to you and tells you that everything should be in the microservices, and you'll try to, and you'll split your application to the microservices and make it works in the Kubernetes. So, what are the disadvantages? First of all, if you have 100, for example, hosts, you should check logs on those 100 hosts. The second one is a slow search over the large files, because if you have, for example, 1 terabyte log file, you should build your script, and after that run the script, and it will take near the 20 seconds on the fastest SSD, because it always should read the information from the disk, and it took some IOPS. So it will not be so fast. And also it's an imperfect support of structured login. No, it's what is structured login? It is logs with arbitrary fields. So what is the solution right now we have? It's the main large-scale login and core principles. First of all, the main system tries to push logs from the large number of hubs to a centralized system, like the main login system doing right now. It's the next core principle, it provides the querying over all the ingested logs. So it should be not just a querying, it should be a fast querying, because you should retrieve your information from the logs system and understand what happened right now, and do not wait, for example, 5 or 10 minutes and get this information. And you should have a structured logs out of the box. So you should see your logs in some structure and understand what happens and how you can do it with this information. So what we have now, it's different solution types. And what are they? First of all, many of you know about the cloud solution. It looks like the main presenters of these cloud solutions are Datadog, Sumo Logic, New Relic, etc. They're one of the big of them. Another solution types at that moment is Elasticsearch, OpenSearch, Grafana Loki, and Victoria Logs. It's on-prem solutions that you can run on your own hosts or on your servers. What the advantages and disadvantages between cloud and on-prem solutions? First of all, operational complexity. Cloud easy, and the cloud provider operates the system for you, so you do not need to implement your infrastructure for that. You just need to get some access point, and you will push your logs to that system. But for on-prem decision, you should create your infrastructure. You should get some architecture for that, or some developers who will operate with this system. But what's the disadvantages? First of all, it's security. On cloud solution, we need to know who has access to your logs, and we should understand, do we really need to push these logs to this cloud, or we do not, and how it who will have the access to your logs, for example. On-prem, it's a good, your logs always under your control, and you always know what happens and who has access to your system. And of course, it's a cost. Cloud solution is very expensive, and if you sometimes read some articles, you should know that some of the cloud providers can be very expensive for different companies. But on-prem, it always depends on your system, how many RAM or CPU you used, which servers do you use, and what do you want from this system, and it will calculate to your cost efficiency. So what's the most, it's on-prem. I will tell you on some comparing of on-prem solutions. It's the most popular solutions right now. I will tell you about how they work, maybe a little bit under the hood, and we will see what's the difference between different solutions. So, what's the main, the first main purpose, first main reason? It's setup and operation. So, if you're talking about Elasticsearch, it's hard and non-trivial ELMS configurations and turning for large volume of logs. Do you know about ELMS? Some of you who use it. Okay. Okay. If you want to understand what is it and how it works and why we should to configure it, you can check this link. So this configs use it if you need to get some more information and more in faster way from the large volume of logs, and it contains near 15 or 20 different config params, and you should understand how it's better to configure them to get your logs in small parts, and if you have small parts of logs and if you have large volume of logs. It's not very trivial to configure it and get this optimal configuration. Another solution is Loki. It's built on microservices, and it's complex to architect and not trivial to configure, because you have different services, and these different services works together and collects some of them collect the information, some of them returns the information, some of them stores the information, and you should know how to configure each part of it, and you should know how it works and how to communicate with each other. So it's not very trivial to configure it. We have our only solution. It works out of the box. You can try to use it. Here is some simple representation of high availability. It's not a cluster, because at that moment we have only a single node, but you can make it high available to share your ingest to the Victoria Logs single node via the logs collector, like Fluentd, Vector, Logstash, and others. And you can get these logs via our component via mouse, which works like load balancer between our single nodes. You shouldn't add some additional configuration files or something like this. You just can download it. You just can download it and run and try to use it on your, for example, production system. The costs. Elasticsearch have a high cost because it requires a lot of RAM and disk space. Why it happens? Because it's related to the architecture of index build for the Elasticsearch. Loki, it's medium. You will pay per each query because the Lokis stores their logs at S3. Do you know what is S3? I mean, I hope you know, yeah? Okay. Most of you will tell that, oh, it's not too expensive, but if you deep dive into AWS, you will see that each query on S3 costs you a lot of money. And you will see that when you try to build a Loki solution and you will get some queries around the Loki, you will get your bills will grow with your requests to the storage. This is QR code, and this is the article from Aliaksandr Valialkin. It's our CTO, and he builds Victoria Metrics and Victoria Logs core. So you can check and you can find and gather there more information about the, why Elasticsearch and Loki are expensive and why their works not perfectly at that moment. And Victoria Logs is a single node, and it can replace 30 nodes of Elasticsearch. It not uses a lot of memory, and it uses forgot this word. Sorry. Also, it's about the full text search. Elastic is very fast, and Loki very slow because it scans all the logs from the index, and Victoria Logs fast has the sum comparable to Elasticsearch. Do you know what means the full text search? Yeah, okay. So I will tell you why it happens, because I will tell you a little bit about the architecture of Elasticsearch Loki at VictoriaLogs and why it works like this. Elasticsearch have inverted index, and it splits the message of the log into tokens and collects them with the message name and tokens and builds some IDs and stores this into the inverted index without any filtration. And after that, they just sort and use binary search to retrieve you the log message. And if you use the full text search, binary index works well, or inverted index works well in that way. But if you need to find some small amount of logs, it's not a good way to use the inverted index. And if you check the articles that I shared before, you will see that while the Elasticsearch builds this index, they collect it into the tokens, and those tokens uses a lot of RAM under the hood. So Elasticsearch needs more RAM to retrieve these logs while you query your information from your system. Loki has another way. They uses under the hood the log merge set and inverted index, so they works well on not a very big amount of data. But if you need to get some very large information from the Loki, you will wait sometimes for maybe 30 minutes, maybe 35 minutes. VictoriaLogs has a little bit different approach. We are using Bloom filters when we build our storage, and all tokens saves into the Bloom filters, and it helps to find any information very fast, because the architecture of Bloom filter helps us to do not get the whole information from the disks and just get some small parts of information that we need and that user entered on the query. So it's the main problem. It's how to efficiency query 100 terabyte of logs. It's main problem, needle in haystack search. No, for example, it's some represents of the problems. This messages represents of the problems of the needle in the haystack. First of all, it's how to get the log messages with a given IP address, or find log messages with a given trace ID, or find all transactions for the given users. It's a hard queries for the logs databases, and they should check mostly everything on your database and get a lot of amount of data to process it. So how it works, how many resources it should, how many resources needed to Elasticsearch to query the 100 terabyte of logs. It's, as you can see, it uses at least 200 terabytes of disk space and 6 terabytes of RAM. No, on the Google Cloud solution or AWS, it costs you near 68,000 per month. Grafana Loki, it's impossible because the query will take an hour to execute. I mean, if you will try to run this needle in haystack search. So why it happens? As I said before, it's because indexes they use under the hood on the storages. And VictoriaLogs run if you run it in the single node and uses the same query, it will use 6 terabytes of disk space, 200 gigabytes of RAM, and 32 virtual CPUs. So your infrastructure will cost near 2,000 K per month. Why it happens, you will ask? It's because we are using some disk optimization, and no, all these solutions use it, but we have some interesting disk compression ratio for the typical logs in the product. So also we have some useful CLI tools. At that moment, Elasticsearch do not have it at all. Grafana Loki has, but it has a very poor integration, so you can't get any information from your system, or it will take a lot of time, and you will not, or you will ever receive any your queries you want to run via the log CLI. We have our log CLI, and I will show you at the end how it works and how you can communicate with your storage. What the features it has? It has scrolling via less, so you can scroll it your queries and check the information you need. It has the searchable history. It have live tailing, aka tail minus F that you have in the Linux system. So also you can use streaming via the Unix pipes. No, it's pretty similar in the code like Unix pipe when you build your query. And also you can check the information about how the command line tool works via this QR code or via this link. Next I want to share some production numbers that we are collected for the last year. So we are running single. It works now in our sandbox and collects the whole information from our Kubernetes cluster. It's pretty huge, and we are running on these Kubernetes clusters our benchmarks for the Victoria metrics and Victoria logs. So we collect all the information from different containers and pods and store them into our storage. At that moment, the logs entries is around 2 billion logs. The original size of logs is 2.5 terabytes. How many we are allocate resources for this? Its memory limit right now is 14 gigabytes. It has 4 CPU, and we use 1 terabyte HDD persistent volume at Google Cloud, because our sandbox works on Google Cloud. And at that moment, we are using 400 gigabytes. At that moment, 2 billion of logs just stores at 400 gigabytes. So if you can see, the compression ratio is around 60x for 2.5 terabyte of logs. You can ask one question: why we are using 1 terabyte disk and do not scale down it? Because our disk usage is 400 gigabytes. And if you know the limitations on Google Cloud at that moment, the disks near 100 gigabyte just can get, I think, 20 megabytes per sec bandwidth when you try to get some information from it, but 1 terabyte disks can get you 120 megabytes per second, if I'm not mistaken. So RAM usage is 400 megabytes. that moment, and we are using 8% of single CPU core for that time when we just pushing the logs to our system and using it, just retrieving some information from it. Query performance, it's very interesting question, and most of you always try to ask what is the performance and how it works if we need to get some information from it. So select all logs for the last 5 minutes. It took near 100 milliseconds, and it will collect 70K logs entries. Do you know the limitation on Elasticsearch? How much logs you can get for one queries? Anyone? I think it's 10,000 and not more. Count the number of logs with error for the last minute. It will take 30 milliseconds since near 6K log entries. And count the number of logs for the last day. It will take 20 milliseconds, and it will return you 5 million log entries. If you want to get some information for 100 days, it will take you 100 milliseconds, and it can return you 500 million log entries. I know, is it quite expressive or not? So, for example, if you need to get some top containers with the biggest number of logs for the 100 days, it will take 500 milliseconds to get this information. And well, for example, you want to count some panic on your Kubernetes cluster, so you can get it for 100 days. It's a very huge time range, if you know. It will take 1 second and return you 1,000. It takes 1 second to return you 1,700 log entries. And another one big problem when you're trying to find some non-existing word, for example, foobar-bus, and if you know why it's a very big problem, this word will not exist on your database, and it should check every log on your database. It's at that moment it's over 2.5 terabyte of data, so to check it, it only takes 3 seconds. And it should check the whole your index, what you have on your database. So what I want to tell you about the Victoria logs, it's easy to set up and operate. You can check our official documentation. You can try it. We have Helm charts. We have Kubernetes operator for it, and also we have just only binaries. And you can try to build it via the Docker. If you need it, I can show you after the meeting how you can get it. It accepts log from different log collectors and protocols. You can see most of them, and you can find in our Helm charts and our repository many implementations with these log collectors and many implementations with these log collectors. Also, it's the lowest RAM usage. No, it's, as I said before, it's uses 30 times less than Elasticsearch and near 10 times less than Loki. It has a fast full text search. It's up to 1000x faster than Loki, but it's pretty similar than the search in the Elasticsearch. It has an excellent integration with traditional command line tools for logs analysis. And it's a perfect log storage for the Kubernetes, because most of you use this on your production Kubernetes systems. Open source and free to use. At that moment, you can use it like open source solution. Our repositories are open, and you can check every code and every integrations that you need. And there are useful links, so you can see general docs. Also, I do not mention it on our presentation. We have our, I showed you some examples, but do not mention it. We have our log querying. It names logsql. It's pretty easy. It's not too hard to understand how it works. I will show some examples. And you can check everything you need on the documentation. Documentation always updates. This documentation was written by the engineers like Aliaksandr, like Roman, me, and other guys. So if you find something wrong or you want to change something, you always can create some feature request, or always you can make some pull requests. It will review and maybe merged, or maybe we will share some information what you can do better, or it will be not acceptable for us, for example. This is useful documentation. You can see the general docs, logsql, how you can build query, vlog CLI, it's how it works, and data integrations, it's different endpoints, how you can ingest your data into the storage. And that's all. I will show you some little information about our storage that works in our Kubernetes cluster. And after that, if you have some questions, you can ask. Is it okay? Okay. Yeah. Okay. So this is log CLI. I will connect to our sandbox production cluster, and we'll show you how it works in real world. Now we enter to the shell command line, so we can check how we can what we can use right now. And for example, if we want to get, okay, I will start from the main problematic question. It's a full search, and we see how it will takes at that moment. So as you can see, it takes 7 seconds, but if you repeat it, it will take 3 seconds. Sorry. I think you know why it happens. Because Linux caches some information on their system, and it can get the information from your cache and do not read it from the disk. But on the first search, it tries to retrieve the full information from the disk reading. And also, you need to understand that there is some network bandwidth that can works not perfectly right now because I have Wi-Fi, etc., etc. Okay, next question. We can check the top 10 Kubernetes container names, and as you can see, it took only 400 milliseconds. And also, I want to share you some information. You can see the execution, and this how my query was converted in our log storage. So it uses top by and the name, but I simplified it a little bit. And write it in that way. And another, I don't know, I will show you some that I tell you about the percentage of errors. Yeah, and you can see what happens here. So first of all, we define the time range for 1 hour. We count total, and count if error. This total, it's a field name. This error, it's a field name, and this is count. It's a function that will count errors. If it's an operator that will search on the messages, just only errors. And this is a pipe that I tell you before, because we just search for time ranges, and after that we this information from time ranges trying to collect information about errors, and after that we use a pipe and just use the mass operator and calculates the percentage of errors where the wall logs. So as you can see, it's 38% right now. And also, what's the next interesting query? I think this one. It's about structured logs. Because we have stream ID here, it's a high cardinality field, and it should take some time to process. Oh, sorry, I forget to enter. I forget to, and you can, as you can see, you can get your messages while scrolling to less. Quite. I forget to enter this. And also, if you forget to enter punctuation, you can use double enter. That's all. That's what I want to show you. And also, I want to share some information. 1 second. It's about the metrics. Oh, sorry. Yeah, here. So, as you can see, right now we have uncompressed data size near 2.8 terabytes logs at that moment. It's a metrics from our sandbox container. That's all. If you have any question, you can ask, please.